Hi, welcome to the demo on DB2 Temporal Data Management. In this demo, let's learn how to implement time travel queries in DB2. To understand the concept of temporal tables and its types, let us consider a few application scenarios. In this example, we have table house with the columns flat number, address, owner name, rent amount, tenant name, and the status of availability of the house. Now the tenant wants to query the house table to know the rent he paid on December 1, 2010. He has not inserted the timestamp during insertion in the house table. Let's see how DB2 helps the tenant to retrieve the information he needs. The support in DB2 for system time enables you to automatically track and manage multiple versions of your data. It transparently keeps a history of updated and deleted rows over time. This feature captures changes made to the state of your table and to save old rows in a history table. A history table is a separate table with the same structure as your current table. This is based on system timestamps that DB2 assigns internally to manage system time, also known as transaction time. Let's learn how to configure system period temporal tables in DB2. First, create a table house as shown below. The table has 3 timestamp 12 columns, SYS start, SYS end and transaction start columns. The first 2 columns are for the start and end points of the system time and one for the transaction start time. DB2 uses the transaction start time column to track when the transaction first executed a statement that changes the table's data. You can define all 3 timestamp columns as generated always, so DB2 will automatically generate these values on insert, update, and delete. This relieves you of specifying values for these columns when writing to the database and ensures that the timestamps are accurate. Optionally, you may define these columns as implicitly hidden so they won't show up in select statements. Step 2 is to create a history table. The structure of this table to be identical to the house table. You can achieve this easily by using a create table-like statement. Finally, alter the current table to enable versioning and identify the history table. We shall now run reorg and run stats on the house table and the history table. Populate the house table by inserting records. Here we need not insert timestamp as DB2 generates for system time columns and transaction start time automatically. This is how the table looks after inserting the records. The history table and transaction start time column of house table are empty because the records are not changed after insert. Let's update the record with flat number 111 with the new rent amount. Then execute commit. DB2 updates the value of the row in the current table. In addition, it moves a copy of the old row to the history table. For both tables, DB2 correctly records the system time start and end values for these rows. In particular, DB2 sets the SYS underscore end column value for this row in the history table to the time of the transaction that issued the update statement. All this occurs automatically and transparently to the user. Let's see what happens when a record, for example, the tenant Mary, is deleted from the table house. When you delete the row, DB2 automatically removes the data from the current table and maintains an old version of the data in the appropriate history table. DB2 sets the end time of the deleted row in the history table to the transaction start time of the delete statement. This happens transparently without any programming or user effort. Users can access this deleted data through queries that contain an appropriate time period specification. Coming back to our tenant query who wants to retrieve the rent amount he paid on a particular time. By using system time as of timestamp in the select query would fetch the results he needs. System time from to enables you to query data from a certain time to a certain time. DB2 uses an inclusive, exclusive approach for this period specification. System time between and enables you to query data between a range of start and times. DB2 uses an inclusive approach for this period specification. The benefits of system period temporal tables are: the insert statements are simple, without timestamp as transactional statements. Enables the user to work with historical data easily, avoiding the need for complex where clauses with various timestamp and join conditions. Built on standards which dramatically reduce temporal query complexity. Compliance and auditing regulations require many organizations to keep a history of data changes so that they go back in time to verify data existence at any given point. Transparently maintain a system history of all data change, with system-generated timestamps which are managed as system time periods. Step into the DB2 time machine and experience the cost-effective means to address auditing and compliance issues. Overall, DB2 helps improve data consistency and quality across the enterprise.